I'm going to talk about Karnaugh maps. These are diagrams that are used for simplifying Boolean algebraic expressions. To understand Karnaugh maps, we need to already be familiar with truth tables in the context of Boolean algebra. That is, we have a set of inputs, a set of logical inputs, and we have a set of logical outputs. What I'm going to demonstrate here is how we take a truth table and we convert it into a Karnaugh map, which is the first stage in the process of allowing us to simplify Boolean expressions. Now, a Karnaugh map is a two-dimensional grid, and I'm going to demonstrate how we create it here. So to begin with, we need to identify our two inputs, which are A and B. /B here, and then along the top we're just going to identify the inputs of B. So we've got two inputs for B, which is 0 and 1, and along the side we have the two inputs for A, which is also 0 and 1. So we'll draw the grid for that. So we've now identified our inputs. Next we need to identify the corresponding outputs. So I'm going to draw these in yellow so you can identify and distinguish between the inputs and the outputs more easily. So we have A as 0 as input, we have B 0 as our input, and if you look at the top line of the truth table, the output for that is 1. So looking at the second line on the truth table, where we have input A is 0 and our input P is 1, our output is also 1, so we put 1 here as well. And the next row, where we have input A is 1, input B is 0, our output is 0. So that's going to be 0 here. And where we have both inputs A and B is 1, our output is 1. So that's our Karnaugh map and represents the first stage in allowing us to convert and simplify a Boolean expression. Once we've created our Karnaugh maps, we then need to draw boxes around groups of adjacent ones. Now it's really important that boxes must only contain ones. Boxes can overlap. They must be square or rectangle, and they must contain a number of cells to the powers of 2. So that's 1, 2, or 4. So let's apply those rules now to drawing our boxes around our groups of 1 here. So let's draw our first box here around our group of ones here. So we're going to do it along the horizontal here. You can see that there we have two groups of ones there. So that's one group. Additionally, we have a group of ones of two ones going down as well, so a vertical set of ones here. So we have two groups of ones. Notice as well they overlap, so we can, as we said, we can have overlapping boxes there. So we've got two boxes, two groups of ones, and they're overlapping. Now the next stage is to take those two boxes and understand what they mean in terms of a Boolean algebra expression, because that's ultimately what we want to get to. So let's take the red box to begin with. You'll notice that for this says that when A is 0, so that is not A, it doesn't matter what the values of B are. So we can say that for the expression that represents the red set here, we can just simply say that that's just not A, because if it's not A, it's always going to be 1 regardless of the value of B. So that represents the expression for the red box here, which is going to be not A. Following a similar sort of logic, we can do it for the blue box as well. So notice here for B, it's 1, consistently 1, but again, it doesn't matter what the value of A is, the values in the blue box are 1. So for this to represent this box here, it's just going to be B, because B is 1 here, so it's going to be B. So therefore we just put B down here. To combine the two boxes together to create our overall algebraic expression, we OR them together. So we put a plus here to indicate that we're ORing the not A or the B. And that's it. That's our simplified Boolean expression there. When we have more than two inputs, we need to represent multiple inputs along each dimension. So for example, in the example we have here, we have 3 inputs. We're going to have to represent 2 of those inputs along the same dimension. Now it doesn't matter which ones we combine along the same dimension, doesn't matter which 2 inputs, it could be A and B, it could be B or C, it could be A and C, it really doesn't matter. But we are going to have it so that we're combining inputs along a dimension. Let's now, in this example here, convert this truth table into the corresponding Karnaugh map. So what we're going to do is we're going to have A going down the side, that's going to be A on its own, and we're going to combine B and C, and this is going to go along the top here. Next we're going to do our inputs for A, which we just have 2 values here, 0 and 1. And along the top here now, we are going to put the inputs for B and C in ordered by grey code, right? So that is only 1 bit changes between cells to the next, between adjacent cells from one next to the other. So let's just have a look in this case what we're going to do. So for B and C here, we start off with our input for B, which is 0, and our input for C, which is 0. Then we're going to do for input for B, which is still going to stay 0, and our input for C is going to be 1. So remember, we're just changing 1 bit. And then we're now going to have it so that we've got B is 1 and C is 1. So that's now our third one along here. And then we've got the fourth one, the remaining combination, which is 1 and 0. So now we've taken account of all different combinations for the inputs for B and C, 0, 0, 0, 1, 1, 1, 1, 0, but in the order of grey code. Next, we're going to just finish off our grid here. And we're going to put in our outputs, which we'll do in yellow again, just so we can distinguish between the inputs and the outputs. So first of all, we've got A is 0, B and C is 0, so our output is 1. And I can get through this quite quickly now. A is 0, B is 0, and C is 1, so therefore it's 1 here. So I'll just go through this really quickly from here on in. I can just write these in, like so. 0, 0, 1, 1. So that's now our completed Karnaugh map. So we've created our Karnaugh map in the same way as we did with the 2 input case. We need to draw boxes around our groups of ones in order to be able to simplify this Boolean expression. So let's do that now. So it's pretty clear now which are groups of ones that we have here. So we have our top group of ones here, which we'll just draw a box around there, and our second pair of ones, which is in the bottom right hand corner here. So those are our 2 groups of ones. So let's now figure out how we express each of those boxes separately as algebraic expressions. So we can see that for this one here, for the top red box here, we can see that C doesn't matter what the value of C is, 0 or 1, regardless, it doesn't matter. but we can see that A is 0, so it's not A, so clearly that is constant there. So if it's not A and it's not B, we can say this is going to be 1. It doesn't matter what C is going to be. So it's going to be for this case here, it's going to be not A and not B. For the green box, what we have is A is now 1. So A is constant here at 1. So we can say that A is going to be part of our input here. It doesn't matter in this case again what C is. It can be 1 or 0. It's always going to be 1 here, but B is also going to be 1 in both cases. So therefore now that green expression now shows that we've created that there. So those are our two expressions for the boxes separately, and again we combine them with the OR operator to give us the overall expression, which is now given here. Let's now move on to truth tables with 4 inputs and how we represent Karnaugh maps with 4 inputs. In this situation, what we have to do is we have to combine our inputs along both of the axes, not just along a single axis as we saw with 3 inputs, but along both axes. So we're going to do this now for A and B, which we're going to have along the side, and then C and D, which we can have along the top. Again, it doesn't matter how we combine them together, it really doesn't matter, but we're going to go A and B together and C and D together. So let's begin by converting our truth table here to a Karnaugh map. So we have A and B here, so we specify that, and B, and then specify C and D. And again, ensuring we put our inputs in the order of grey code here. So we've got 0, 0, 0, 1, 1, 1, 1, 0. And we do the same thing now down the side. So we've got 0, 0, 0, 1, 1, 1, 1, 0. And let's draw the grid for that. And then we fill our table in for our outputs. Again, we'll do it in yellow just to distinguish the inputs from the outputs, and we'll fill this in now. So the top row here we have input A, B, C, and D all 0, so our output is 0. So I'll again fill this in quickly. 0, so that's 0, 1, 1, 0. That's 0, 0, 1, 1, and 0, 0, 1, 1. So that's now our completed Karnaugh map for 4 inputs. As before, for the 2 input and 3 input cases, we're going to group our ones in boxes. So our first group here, you can see we have 4 ones here as a square, so that's our first box. And then our second box in the bottom right hand corner here, we will draw that round out with the green box. So now we need to derive our Boolean expression from this. So we can see here that we have not A as our input for the red box here. So not A, that's consistent. It doesn't matter what B is in this case. It's going to be 1, and we can see that C 0 1 again doesn't matter what C is, but it's going to be D is consistently at 1. So our inputs now, or our expression that corresponds to this red box here, is going to be not A. So let's do this in red. So it's going to be not A, and it's going to be, well, D is 1 in all cases. It's going to be D. So it's going to be not A and D. So that's for our red box. And moving to our green box, A is now 1 for our box here. But again, it doesn't matter what B is. And in this case, C is 1 for our input in both cases, for both cases of this box. Again, doesn't matter what D is, it could be 1 or 0, it's not going to have an effect on that. So therefore, we've got A as our input here, and is going to be C. And as before, we combine those separate expressions to give our overall Boolean expressions with the OR operator here, and that now is our final overall Boolean expression for that truth table and Karnaugh map. Let's now have a look at 4 input Karnaugh maps. So remember, the first step is to group our ones here. So we have a group of ones here. So we can draw a box around those group of ones, and we also have a group of ones here as well. So those are our 2 groups of ones. So let's now try to derive our Boolean expression from this. So we know here that we have not A but zeros in both cases for A there. It doesn't matter what B is, so we can start by saying that we've got not A there along the, if we just take the vertical dimension here. Let's have a look along the horizontal dimension. We can see that C, 0, 1, again, doesn't matter, but D is 1 in both cases, so therefore we've got not A and D here. And then we want to combine those 2 boxes using the OR operator here. And we now have A is 1, so therefore it's just simply A here. And again, it doesn't matter what the value of B is. We've got C here to be 1, so that's now in both cases here. So that's C, and it doesn't matter what D is, so that's going to be that. So that now is our final Boolean expression there. Now we could go for 5 and 6 inputs, but we're not going to. We're just going to keep it for 2, 3, and 4 input Karnaugh maps. I want to explore this idea of the overlapping edge that we might have. Now it looks at first glance that we have 4 groups of ones here, so 4 boxes. So we might have a box that's indicated here. We might have a box that's indicated here. That might be a box that's indicated here, and a box indicated here. But actually what we've got is not 4 different boxes, but actually 2 boxes, because we overlap from left to right. So that's why we have grey code here, because it's like an overlap. So we get to 1, 0, and then we go back to 0, 0. So actually, from left to right, the edges wrap around, and from top to bottom, the edges wrap around. So let's now demonstrate that with the actual boxes that we're going to draw here. So one box will actually represent these 2 and also these 2 ones here, and our other box will represent these 2 here and these 2 groups of ones here as well. So that's actually one box there. So that's because it wraps around. So now that we've drawn our boxes, again we can apply our Boolean algebra in the same way as before. So let's do that now. So that's starting with the red box. So what we're saying here for the red box is that A, doesn't matter what A is, 0, 0, 1 doesn't matter, but B is consistently 1, so we know it's B there. And looking along the top here, it doesn't matter what C is, but it's not D. D is 0 in both cases here. You can see that. So that's not D, B and not D. and then for the box, which the green box, the expression for that is going to be, well, A, 0 and 1 doesn't matter. B, it's going to be not B, it's 0 in both cases, at the top and at the bottom. And for C, again, it's 0 and 1. So that's it's not C, but it's going to be D. D is 1 in both cases. So that's going to be and D. So that now, when I combine it with the OR operator, gives us the complete Boolean expression for that truth table and Karnaugh map.